All right, section 2.6, graphs and basic functions. So in this section, we're going to learn a lot of different types of graphs, okay? And just for a precursor for tomorrow, for 2.7, all of these graphs are going to be called parent functions. Okay. Again, it'll make more sense tomorrow, but for now, we'll call them parent functions. So you won't have to memorize these functions. You're just going to know what they look like, because we're going to use them for tomorrow for next section. That's the reason why. So that's why this is pretty short, because a lot of it is just used in the next section when it comes to it. Okay. So we have, I think, a total of 5 or 6 different functions that are called parent functions. And all we're going to do is just quickly draw them and just do some basic information from it. And then again, we'll use them far more in the next section when it comes to it. So first thing is, how do we graph x squared? Okay. So x squared is called a parabola, and it looks something like this. Like that. Where it's increasing from 0 to the infinity this way, and it's decreasing from negative infinity to 0 that way. So that's why it's going a downtrend and then an uptrend on the other way. Okay. So again, the main concept what we care about is just being able to identify what it is. So x squared, a parabola, always means a U shape this way. Okay. X to the third is a little different. It goes like this. So it's kind of like a parabola, but it's on its side, and one is flipped on the other side like that. Okay. And believe it or not, it is actually increasing everywhere, right? So it always goes up. So it's all like goes this way, always goes. It's always an increasing function when it comes to it. All right, next one is the square root of x, which we talked about before, right? How to solve for these. So the square root of x looks like this. It's actually 1/2 of x to the third. So meaning it doesn't exist on this side, it just starts it there. And like it says, right, so it's always increasing. So from 0 to infinity, it's always going up. Couple more. Next is the cube root of x. And the cube root of x actually follows this one, because it also goes just like that. The only difference is like this shrinks a little bit when it comes to it, but you know, it's just a sketch of it. Okay. And the last one we talked about is the absolute values, right? We've also solved how to solve absolute values. And absolute values are just like parabolas, except instead of a U-shaped, they are V-shaped. That is the only difference between absolute value graphs and parabolas, x squareds. So x squareds look like a U, absolute values look like a V. And same process, right? It decreases here and increases there. So like I said, so we have 1, 2, 3, 4, 5. So these are called parent functions. And again, you'll get more understanding what I mean by a parent function in 2.7. But for now, all we care about is just understanding what they look like. You know, if we have x squared, okay, what does that look like? If you have absolute value, what does that look like? And so forth down the line. Okay. So the main concept when it comes to this section is something called a piecewise function. So piecewise functions are different functions put together. So you can kind of think like a Frankenstein. You know, you have the bits and pieces of each one individually put together and make one big graph. So it could be, that's where you see those big, increasing, decrease function, constant functions, where it goes up, down, loop, slash, all that stuff. It's based, that's what these concept piecewise functions. It's like bits and pieces of all of these graphs that are put together into one big graph here. Okay? And that's what we're going to talk about pretty much for this section, pretty much to finish up this section. Okay? So the most difficult part is actually graphing it when it comes to it. And again, we'll take our time when it comes to graphing it. On the test, you won't actually have to graph it. All I'm asking to verify is just know how to do like the part A stuff. Graphing it on this one's gonna be too hard when it comes to like testing on online stuff. Okay, so you guys get lucked out there. Okay. So how a piecewise function ends up broken down is you're actually given rules. Okay, and these rules will always be given to you as well. Okay, so what this is saying is we have two different functions. The first one's here, and the second one is there. Okay, what it's saying is I'm only using the first one if I have a value that satisfies this condition. I'm only using the bottom one if I have a value that satisfies this condition. So this is why I say it's literally just rules. You just follow the rules when it comes to it. It's telling you what to choose, and you got to figure out which rule you actually be using. Okay. So, for example, let's suppose we want to find f of -1. Now remember, what this saying is, if x equals -1, what is the y value we're looking for, right? So if x equals -1, which one of these does it satisfy? You can say, top or bottom in the chat if you guys can say. So which one does -1 satisfy, the top or the bottom one?
Top.
Top, right? X -1 is less than or equal to 0. And notice it doesn't equal, right? So it's either going to be one or the other. It's never going to be both, which is the best part. So it only satisfies the top. So therefore, I'm only plugging into here and not there. That's why I say is you're going to pick one or the other depending on the rules given to you. So therefore, to find f of -1, I'm only going to be putting it into the top one itself. So it'd be -1 plus 2. Which equals 1. And we just keep going. So next one, f of 0. So again, this is saying x equals 0, right, when it comes to it. And we just got to satisfy which one goes to it. So again, if x is 0, which one of these are satisfied? Well, again, the top, right, because it could be equal to 0. So again, we just satisfy the top. So I'm going to plug in 0 plus 2, because that's what it's telling me to do. And this gives you just 2. Right, and the last one here. So this saying is what happens when x equals 2. So now, again, I just ask which one is satisfied. And now notice that now it satisfies only the bottom one, right? Because 2 is not less than 0, but 2 is greater than 1. So therefore, I'm going to plug into only here. So this is going to end up being 2 squared, which is just 4. And there's your answer. So that is how you plug in values in a piecewise function. You have to figure out what rule you're going to be using, and then just plug it into that particular one. So that's why it says if this is true. So we use this if this is true. We use this if this is true. So any questions there at all? Everybody comfortable? Okay. So now the graphing part is a little difficult when it comes to it. So I just want to show you guys how this is going to be graphed. So again, we're just going to plug it using a t-table. However, we're going to plug it in using the values we have here. Okay. So x could be at most 0, right? So anything below 0 is perfectly fine. So it's like 0, -1, -2 work, right? Those are satisfied that inequality. And same thing applies here. We're going to pick numbers that are bigger. So 2 works, 3 works, when it comes to it. And now we're just going to plug in chunk. So plug in 0. Well, we already have that. Right? We did that. That's 2. Plug in -1. Well, we also have that as well. It's also 1. So we did both those answers. Plug in -2. So -2 plus 0 gives you 0. And so we're just going to graph this. So 0 up to -1, 1, -2, 2, 0. So this one keeps going, right? I can keep going, -5, 100 works. So this is going to go down that way. And now we do the same thing on the other side. So we did this one earlier. That's 4. Plug in 3. So 3 squared gives you 9. So if I go to 2 to 4, and then 3 9-ish. So this is going up that way. Now, why only this way, right? Why not this way? Because my minimum is 2, right? But does that work? You guys can say, yes or no in the chat or something. Does 1.5 satisfy this condition?
Yes.
Yeah, right. 1.5 is bigger than 1, so we can plug it in and square it. But that's a lot of numbers, right? Like 1.11 works, 1.001 works. So like, how do we stop? So to do so is, let's suppose, imaginary, right? This is just imagine that 1 did satisfy this. I know it doesn't, right? I know it doesn't, but let's suppose it did. What would that be? So if I plug it in, that gives me 1 squared gives you 1 out, right? So if I plot 1, 1, so instead of a whole number, I'm going to make a circle like that. What that's saying is, I'm not including this number, but that's technically going to be our starting point because any number after that is okay to use. And that's what makes piecewise functions very difficult, because now we have holes in the graph and we have spaces in the graphs as well when it comes to this, because this is actually not connected. It's like a space between here and there. Okay. So a little unusual, right? So don't stress too much out when it comes to piecewise functions. Every time you see this, you always get a good review when it comes to it, because they're pretty difficult concept when it comes to it. But the main focus for now is, are you comfortable doing these ones here? GraphMM is a little funky. Okay. So let's just try one more example, so you guys can see what the rules when it comes to it. So again, right, a piecewise function is made up of multiple parts. So this one is saying this piecewise function is made up of 3 different graphs. The first one, the second one, and the third one down here. Okay. And again, each one has its own specific rule applied to it. Okay. So first, find f of -4. Okay, so we got to figure out which one is satisfied when we plug in -4, right? So if I go to our scenarios here, thank you. Does it satisfy the top, middle, or bottom? What do you guys think? So remember, this is when x equals -4. Which one does it satisfy? So top, middle, or bottom? Anybody there? Okay, so that's at the top. Good. So I get somebody paying attention at least. So it satisfies the top, right? Because -4 is less than -1, right? So it satisfies the top. So I'm only going to plug in to there only. So be -3 times -4, which is 12, right? And there's your answer. And keep going. Next one is -1. So this is a trick question. Because remember, you're only going to be using one of the three. So if x equals -1, well, it doesn't satisfy this one. It doesn't satisfy this one. And look at that. If x equals -1, which is in this case, we use exactly 2. So it's literally just 2. We don't plug anything. It just literally tells me I'm only using 2. Did I lose anybody there? Everybody good for that one? So okay. Okay. And the last one, what happens if I plug in 2? The bottom one, good. Right, so that's the only one. So this is going to be 2 square root of 2. I don't know what that is, but you know, that's good enough there. If you really want, you could just plug in a calculator and get it out. It's like probably going to be like almost 4 something. So there you go. Those are the answers there. And now again, just to graph it, we're just going to graph each one individually. Okay. So this one's going to be for the top. So again, right, everything less than -1. So say -2, -3, and so forth. And notice we actually did, let's go -4. We did -4. So we did -4, that's 12. -2, so -2 times -3 is +6. -3 times -3 is +9. Okay, so if we just again graph these out, so -2, +6. It's going to be way off our chart, but not too bad. Okay, and again, if -1 was possible, we would get out +3. So that means we'd have a hole right here, and then connect the dots accordingly, like that. Because then the reason why we do this is because -1.5 works, -1.1 works, right? So all of those numbers in between here work. So we have to actually graph that as well. All right, the middle one is actually very easy because there's only one point. That's the only thing that satisfies, right? There's no other point that satisfies it. So this is just -1, 2. So it's just one single point there because there's nothing else that satisfies, right? There's no other number besides -1 that works. So that's a good one, right? And then lastly, do the same thing for the other side. Okay. So everything greater than 0. So 0 works. 1 works. And let's say 4 because I don't know what the square root of 2 is. So if I plug in 0, square root of 0 is 0. And then 0 times 2 is 0. It's kind of nice. Plug in 1. Square root of 1 is just 1. And then 1 times 2 is just 2. And if I plug in 4, that's 2 times 2, which is also 4, right? So this is going to be 0, 0, 1, 2, and then 4, 4. So it looks like that. So pretty crazy, huh, when it comes to it. So like I said, these are pretty difficult to graph because, you know, you have to memorize a lot of different stuff, a lot of different rule set when it comes to it. So if you're not comfortable graphing, don't worry about it. right now, just are you comfortable just finding values given the rules itself when it comes to it? Okay, I know the homework will ask you to graph it, but it won't be as much graphing when it comes to it. Okay, things like that. So, any questions on this example at all? So all good.